Now let's try example 4, question number 2. You have been asked to design a 1 liter oil can shaped like a right circular cylinder as illustrated below. What dimensions will use the least material? So we know that the amount of material is directly related to the amount of the surface area of the cylinder. Therefore, we're going to use A as our function in order to solve this problem. So A, the area of the cylinder, is equal to 2 pi r squared plus 2 pi r h, where 2 pi r squared is the total area for the bottom and the top of the cylinder, and 2 pi r h is the area for the wall of the cylinder. And in order to find the first derivative of A, we can only express A in terms of R or A in terms of H, only either one. So in order to do that, we need to express either R in terms of H or H in terms of R. So we can do that by using the equation of volume of the cylinder, which is V equals pi r squared h. And in this case, it is given that the volume is equal to 1 liter, which is equivalent to 1000 centimeter cube. So we take that as 1000 equals pi r squared h. So h is equal to 1000 over pi r squared. So by substituting h equal 1000 over pi r squared into A, we get A equals to 2 pi r squared plus 2 pi r times 1000 over pi r squared. And finally, A is equal to 2 pi r squared plus 2000 over r. So now that we have the expression of A in terms of r, we can differentiate A with respect to r. So dA dr is equal to 4 pi r minus 2000 over r squared. And now we need to find the value of r when A is either maximum or minimum, which is when dA dr equals 0. So when dA dr is equal to 0, 4 pi r minus 2000 over r squared is equal to 0. Then we have that 4 pi r cube is equal to 2000. Just rearrange everything, and then finally we have r cube equals 500 over pi, and then r is equal to the cube root of 500 over pi. And now we need to carry out the second derivative test just to check or to verify whether that value of r would give a maximum or minimum value for A. So the second derivative of A with respect to r is equal to 4 pi plus 4000 over r cubed. So when r is equal to 500 over pi to the power of 1 over 3, the second derivative is equal to 4 pi plus 4000 over 500 over pi to the power of 1 over 3 to the power of 1 over 3. So that gives us 4 pi plus 8 pi, which is equal to 12 pi. And 12 pi is greater than 0. Hence, we can say that that value of r would give the minimum value for a. And now that we have verified everything, we need to find the value of h that corresponds to that value of r. So when r is equal to 500 over pi to the power of 1 over 3 or 5.1293 centimeter, h is equal to 1000 over pi r squared, which is equal to 1000 over pi times 500 over pi to the power of 1 over 3 squared, which is equal to 10.8385 centimeter. So finally we can conclude that the can uses the least material when r is equal to 5.2 centimeter and when h is equal to 10.84 centimeter. So that's all for example 4, question number 2.